Um, yeah, so in the last class, we stopped until seeing the three areas of Git workspace. That is, we'll have a working directory, a staging area, and a Git repository, right? That is what we were saying. So now, just one more thing which you need to know is how does a file gets created and how does the state of the file moves is what just an information which you need to know. So now, whenever you are working on a file, generally the content of the file will be stored in the repository, all right? That means what Git calls them as tracked files, or if there is a file which it is being maintained in the Git repository, that means Git is been tracking that file. Okay, so in that case, now whenever you have a file in the working directory and you're doing some changes, with respect to the changes what you have put here, it will be trying to tell you whether you have modified something by comparing it with the content what it has stored in the repository. Okay, so that is how at any given point of time, if you ask Git to give the status of the file, it will tell whether the file has been modified or unmodified. So whenever for the first time when you are having the files, it will be called as unmodified because whatever content that you have in your working directory will be same as what you have in the repository. Hence, it will be called as unmodified. But as soon as you modify something here, then Git will try to compare with what content you have here and what you had in the repository. If it finds any change or modifications, then it will call the files as unmodified, or automatically it identifies that you have modified something. And what will you do? After you have modified the files, you will stage the files, right? And what do you mean by staging? You will try to take this file and put into an area for taking snapshot, and then you do a commit. Now, as soon as you do a commit, what will happen internally? It will be creating a commit ID. But when it creates a commit ID, what does it mean to this file? Whatever content that you have in this working directory is going to be the same which is getting stored in the repository. So now automatically the file will become in unmodified because both the states or both the content of the file which is present in your working directory in a Git repository is called same, and that is why it will be calling it as unmodified. Okay, but as soon as you create a new file completely, so what will happen there is these files will not be present in the repository, which means when you create a new file here, there will not be any record of those file existing in the repository. So in those cases, that new files will be called as untracked because untracked means Git doesn't contain any information about its previous existence in the repository. So that is how when you are creating a file for the first time, it will be calling it as untracked. And after that, when you try to add it to the repository, then the file will become unmodified because the content what you have in the working directory will be same as the Git repository. So going forward, if you do some changes, it will be called as modified when comparing to the content of the repository. And once you store it again to the repository, then the file will become a unmodified state because both the contents are same. Okay, so this will be the life cycle of Git which it traverses from. For the first time, it will be untracked when you're creating a new file. Then it will go with unmodified, modified, and the stage content. Okay, so whenever we are working on the files, this is about the stage that we'll be going through. So with this basics of what we saw yesterday from the how the commit happens and what is the life cycle and what is the staging area and how does it work, we will proceed with seeing the practicals. Okay, so before getting into the practicals, the first thing is we need to install. So there's not a big deal in installing. All you have to do is let us just go to the Git site and you can Git download any latest version which you have. Okay, so now if you see you have various versions of Git based on the operating system that you're going to work. So typically, the way that we are going to work is going to be the same either in Linux or Windows. The only difference is the binary of the Git itself will be changing, but whatever that you work on Windows, the commands will be the same on Mac or Linux. There is no difference in that. But the only thing is how you're going to install is what is going to be changing. But still, there is no difference between all those things. Suppose if you're using a Linux or Mac OS, corresponding to it, you will be getting a package which you have to just extract. Suppose it is Windows, it is still much more easier, wherein if you double click, you will be getting a exe, which is nothing but an installer. And if you just install and keep next, next, it'll be just downloading. So you don't have to do anything for that. Okay. So make sure that you install any particular installer specific to your operating system, and just for making it to be a little simpler, I'm using it on a Windows operating system, whereas as I said, there is no difference between using it on Linux or Mac OS or Windows, because when you're trying to use the commands, it is going to be the same. Okay, so in that case, I have just, if you click on this specifically, you will be getting the operating system package. So by default, if you see whatever that currently we are working on the operating system like Windows 7 or anything above that comes as a 64-bit. So you can just click on the 64-bit Windows executable and you will get this exe. Okay, when you just save and double click, it will install Git. You don't have to do anything for that. Okay, so once you have downloaded this and installed, what you will get is, if you go to your Windows prompt, you will be seeing something called as git bash. It is only in Windows. Whereas if you're working on Linux or Unix or any other Mac operating system, you will not be getting this. It is only in Windows. Now, what is this and why do we need this? If we are going to work on Git or any other command prompt, generally in Windows, we will be using a command prompt, something like this, right? So we can use whatever commands we want, anything that is specific to Windows, we can work. But the difference here is this Windows prompt, whatever that we will be using generally in Windows, will support only Windows based commands. Okay, but when you are installing this Git client, it will give you a bash command prompt. A bash is nothing but a command prompt for Unix. So just like in Windows, we call this as CMD or command prompt for Windows. Similarly, in Linux or Unix, we call it as a bash prompt. Okay, so when you install Git for Windows, it additionally gives you this git bash command. And the difference between why we need this is it will be similar to whatever commands that you are running it on a Windows for Git. But additionally, you can type certain Linux commands which we cannot run it on this Windows prompt. Okay, so why is that I'm telling to you is because instead of using this, I'll be using this bash git prompt, which will help us to have a close feel of working on a Linux environment. So just like how we are going to work on a Linux environment, we will be having the feel and the environment will support all those basic commands which we will be working on Linux. Okay, but the same thing if you're using on a Windows prompt, still it'll all be working from the git commands, but the only difference is certain Linux commands will not be working because it is a Windows operating system. So that is the only difference. And I preferred you guys, if you're using Windows, then always use this bash prompt. As you can go here, you will be getting one git bash which has been installed. Here, the advantage or the dual advantage here is you can work on the git and at the same thing, you will be working on Linux commands which this prompt will be supporting, whereas this will not be supporting because this is a Windows based prompt and this is a prompt for Linux based, which Git is going to support. Okay, now this is one of the important thing what we'll be doing it in the class. And the second thing, now whenever we are working on Windows, what will happen is if you install something, there is an environment variable called path, or if you see this, or have you heard of this environment variable called path anytime before?
No.
Okay, so for example, if I type this, what is this dir? Dir is a Windows command which is going to display all the list of directories and files which is present in a folder. Okay, fine. Now see this. If I type the same thing, something like this, it says that it is not recognized as a command. So how does this command prompt or the operating system knows that dir is a command of the operating system, whereas if you type anything else, it is not a command? So in the same way, there might be many commands which by default the operating system uses. Okay, so how does it differentiate generally is because of this environment path called, sorry, it is because of the environment variable called path. So in every operating system, it might be Windows or Linux, what we have to do is we have to add the path of the command where it is present. So for example, if you say dir, this dir is nothing but a executable which will be present in Windows System 32 folder. Okay, so now the path has to be added into this. So like this, no matter what kind of binary or executable that you're going to use, you have to add the complete directory or the path where it is present. Okay, only then when you run the command, whatever that you run, what the operating system will do is first it will search in all the directories or the folders that you have given separated by colon. Okay, so it will check like this: whatever the file that you have entered, is it present in any of the location that you have specified here? If it is present, then it will run. Suppose if it is not available in any of this location, then it will say that I don't know what is that you are trying to tell. So in the same way, when you are installing Git, if it is Windows, what you have to do is we would be calling Git directly like this. Okay, wherein this is the executable which we have got by installing Git. Now, in order to invoke Git, by default, this operating system will not know anything about it. Okay, so what we have to do for that is wherever we have installed Git, we have to find out that location and give the complete path of where it is present. So if you see, I have installed Git in this location. Okay, let me show you that. So now if you go back, you will be getting all the executables like this. If not, if you don't know, you can just go here, right click and try to see where it has been installed. So like this, you can basically find out where the Git has installed. Let me get here. Okay, so if you see, this is where I have installed the Git. Whenever I told you, right, I downloaded and I have installed it in the same way what I told you. It has been installed in this place. Okay, so now if you see here, it has the executable or the application called Git, using which we will be running the Git. So now when I simply type Git from here, Windows will not be knowing or the operating system will not be knowing. So for that, what we have to do is we have to take the path. This is the path where the Git application is available. So this directory has to be added to the environment variable called path. Okay, so only then when we run it, automatically the operating system will go into all the directories, and when it comes to this directory here, okay, it will find this application and it will run. So the very first thing what you need to do is when sorry, whenever you are installing some application and when you want to run this from the command prompt, you have to go to this environment path and add the directory to this. Okay, so in that case, how do you add an environment variable in Windows is, if you go to the computer, right click, you will get a properties, and here if you see advanced system settings, and if you go here in the advanced, you will get a variable called environment variable. Okay, so here if you can scroll down, you will find the path. So just click on this, click edit, and at the end what you have to do is just add a semicolon and the path of whatever that you want to add, so that the environment variable will add the new value which you have put, so that once you close this, the next time when you open a command prompt and you try to print the value like this. So here path is nothing but the environment variable, and in order to get the path or the value of environment variable called path in Windows, you have to use percentage colon percentage. Okay, suppose if it is Linux, there is a different way which I will tell you a little later, but you don't have to worry for all those things, because if you use this git bash prompt, it will automatically would have added, because this prompt whatever that we are using is specific to git. Okay, so now for example, if you see, by default it will add the path of wherever that you have taken. So if you are working on this Windows prompt, then you have to go to this environment variable path and add the place where you have installed. If not, better to use this git bash prompt which is giving, or which has been given by the git, which will have all the details, and directly you can open and you can run like this, which will tell you whether it is working fine or not. So now if you see, it is working completely fine, because this bash defaultly understands where it has been installed, because this command prompt is being given by the git itself, so it knows where the installation that you have done. Okay, so for git specifically we will be using this, because there is no difference from using the Windows prompt or this. The only difference is this will support only the Windows commands, whereas this will support all the Linux commands. So for example, if I'm creating a new file, it is easy to use this prompt, because we can use certain commands of Linux which will help us to create files easily. Okay, so that will not be easy in here. So we will go through that way. Okay, now once you have done, the next thing what you have to do is just verify whether it has been installed. So if you just type git version, you should get some output here which will say what is the version that you have installed. So that means installation is fine and you don't have to do anything. Then the first thing what you have to do after that is set some configuration. Okay, so when I say configuration, there are certain values which you have to set based on which Git will be working. For example, you can set what is the color of the screen that you want to enter. Okay, and you can say who is the user who is trying to modify, and what is the email of the person, and like that there are many things. Like you can set the screen size, width size, all those things, which is not so important, but there are few things which is quite important when you are working on Git for the first time. So these configurations has to be done. And when you're doing the configuration, configuration can be done in two ways, that is local configuration and global configuration. Okay, so now what do you mean by local and global? To keep it simple, as I was telling you, in a given machine, a user can create multiple workspaces, right? So now if you want to have configuration specific to a workspace, then you have to create it as a local configuration. That means whatever the values that you set, it will be applicable only to that workspace. If not, if you want to apply a configuration which is going to be taken throughout the system, that means now no matter how many workspaces that you create, the same value, whatever that you're going to apply, will be taken into consideration, then it will be called as global values, which means the same thing will across all the workspace. In general, we don't prefer local configuration because it is a headache. Every time you create a new workspace, you have to define. Instead of that, we will always be setting a global configuration which will be applied to all the workspaces which has been created on this machine and using this installation of Git what we have done. Okay, so first thing, let's see what and all is that. So the first configuration which you will be setting it up is username. And for setting a configuration, you will be using a command called config. So all these commands will be followed by calling a command called git followed by the command name. Okay, so we will be setting it up like this, wherein git is the actual command which is going to invoke git. For that, you have to pass an option called config. And in git, all the options are very easy to remember because it is going to represent the purpose of why we are using it. So as you see here, config is a short term for configuration. Okay, so that means git config is used to set the configuration, and hyphen hyphen global is going to represent you are setting the configuration globally. And what configuration you are trying to do, you are setting something called user.name. Okay, so here I will say the username as Adam. Okay, now once that is done, the second thing what we need to set is the user email. So we will set the user email. Let me set the user email. Okay, and after that there is one more thing called push.default. Okay, so don't worry about what is this for now. I will be telling it in deep little later. So now once you have done this too, the next thing is you need to set something called push.default, which is simple. Okay, so now we have set all the values which is mandatory. Now, how do you check whether it has been set or not? For that, you can use the same command called git config -list, which will give you all the details. So if you just say config -list, and you can see here all those value that whatever that we set has been considered, but along with that there are certain other default configurations like the color, the screen size, all those things which are not very much important and mandatory. Okay, so now with this basic configurations, we are going to proceed with working. So now whenever we are working, it will be using these configurations. Okay, and why these configurations are required, we will see it little later. That is how you will be knowing. For now, we will be setting the username, email, and one more thing called push.default as simple value. So basically we are ready with our configuration. Okay, so now let's move ahead. So to begin with, now if you see what we will be doing is, very first thing what we need to do is we have to create the repository. So as I said, in Git, we do not have a client and server. So everything is going to be working based on our local Git what we have installed. Okay, so in that case, everything what we are going to work is basically a workspace, and inside the workspace, it is a repository. Okay, so now the first thing which you have to be clear here is when you're working on Git, there are two types of repositories. So one is bare repository, the other is non-bare repository. So what is the difference between bare and non-bare repository? That is what we need to remember, because in any other tool, there is only one repository. And what is that going to do? If you remember, it is a central repository where you will be storing everything in a server, right? And will that be used for modification? No. But in Git, what did I say? Every workspace will have its own repository wherein user can modify. So now, because of that, there are two kinds of repositories where we can either use a workspace to modify and at the same time to store, or we can use a workspace only to store. Okay, so now what is that difference? Let me quickly go back to yesterday's slide, what I was showing, so that it will be clear. So see here. So now when you take a model like this, the central repository is a place where you will not be modifying anything, right? But in Git, if you see, each workspace will have its own repository, wherein this user can modify the contents of the workspace and the contents of the repository. So these kind of repositories where you can modify and at the same time store the changes is what we call as a non-bare repository. Understand this? Repositories in which we can modify and at the same time store the contents is what we call it as non-bare repositories. By default, all the user workspaces are going to be non-bare repositories. That means user will be going to modify the content, right, and do some changes. So in that case, those are going to be called as non-bare repositories. So what is the opposite of non-bare? Non-bare's opposite is bare, which means you will use it only to store but not to modify. Okay, so when are the scenarios where a user doesn't want to modify anything but only to store? These are nothing but central repositories. Like I said yesterday, either you can share it between a user or you can follow a process wherein you can maintain a central repository in which all the users will sync their changes to that and maintain it only for storing and maintaining, so that if some user wants to get the change from other guy, it will not be directly from the workspace of the other user. They will first sync the change to the central repository, and from the central repository they will be taking the changes to their workspace. So these kind of central workspaces or remote workspaces we generally call, because it will be present in some other machine and not on your same machine. Okay, so in that case, now if any other user wants to know what is the latest changes that is available, he doesn't have to worry about individual developer or the user. He can just directly go to this central workspace or the remote workspace and take the changes from this. Okay, so these kind of workspace or the repositories where we only store and not to do any kind of changes is what we call it as bare repositories. Is that clear? To be very simple, bare repositories are those repositories where you cannot do any modification, whereas only store. And non-bare repositories are those repositories where you can do the modification and at the same time you can store changes. Okay, so a good example for non-bare repositories are general users workspace or users repository, wherein all central repositories or remote repositories are going to act as bare repositories. Okay, so that is the difference between bare and non-bare repositories. Is that clear? Any questions or doubts on that before we proceed?
Uh, Adam, it's me, Sam. I just have a question. So before, while we were talking about the bare repositories and non-bare repositories, it's clear, I understood, but I just have one. I don't know if it's dumb, but from the previous, when you said command prompt, you explained us how to use the command prompts, and you showed us how to configure. So I was just wondering, like, why do we need Windows command prompt when we already have Bash command prompt? So you're saying, are you showing us just in case if you want to use the Bash command prompt, I mean, sorry, the Bash commands on Windows command prompts, that's when you have to configure, or do you have to configure to make the Bash command prompt work on Windows? Do you want
Okay,
me to repeat my question? Am I
I got
clear?
it. I got it. So by default, when you're installing any application on Windows and you want to work through commands, then it will always be working only through this. Okay, and you will not be getting anything like this for other applications. So everything has to be worked from this Windows command prompt only. So in order to work on this, you need to set that path environment variable. So I'm just giving an information on how it works. But it is an exceptional case in Git when you're installing a Git application on Windows. What it will do is additionally, it will also give a git bash command prompt, which is additional along with the Git application. Whereas if you take any other application when you install and you want to work from command prompt, for example, in the next class, we will be seeing from the Maven, but that means Maven as in build tool. So when you want to invoke Maven from the command prompt, then you will not be getting something like this. Everything has to be run from the Windows command prompt. So at that point of time, again, what you have to do is you have to see where the Maven's installation is done and where is the binary or the application which we will be using. And that path should have been added to the environment variable called path. Getting it?
Yeah.
Yeah, the only
I'm
advantage.
sorry. Go ahead. Go ahead. I'm sorry. Go ahead.
Now, only difference is when you install Git, an additional prompt along with the application will come. That is what you get here, wherein the advantage here is you don't have to set any environment variable. By default, it will already set. That is what I'm trying to say.
Okay. Okay. I got it. I understood now. Thank you.
And the additional difference is like I can go ahead and still use the same thing. Whatever I did now, I can still do the same thing. Git config, global, whatever, it will still work. But only difference here is when you are working on Linux, it is the same command what you will be using. But certain commands which you use on a daily basis will be applicable only if you use this, and that cannot be worked. So that is why I'm just trying to give you a similar environment of how you will be working on your production. So that is how whatever that we are doing, you will be having the same look and feel. Okay.
Okay. Okay. Yeah.
Okay. Other than that, anything about the bare and not bare repositories, Shashank?
It's clear, Adam.
Okay. So now, so as I said, let's begin by creating a workspace or a repository. So going forward, when I say workspace or repository, both is going to point the same directory, because workspace is a directory where you're going to do everything, and inside the workspace you will be having the repository. So many times, we will be referring it with different terms. Sometimes we will call it as workspace, or sometimes you will call it as repository, but both are going to represent the same directory on which you're working. Okay, so now in order to work on Git, we will be using this prompt. So let me just create a separate directory just to make sure that all the files are stored separately. But other than that, there is no hard code rule like this is where you should create. So for the understanding purpose, what I'm going to do is I will put all the things in a separate folder like this. Okay, so going forward, all those Git related repositories or workspaces which we will create will be present here. So let me delete all those things which is there previous. Okay, now for example, if you see this command called ls, command called rm, command called clear, all these things are Linux based commands. Okay, so this will not be available in Windows. So now suppose if I have to delete a file or a folder, I have to go open up the command prompt or the Windows prompt and then basically right click and delete all those things. So instead of that, I'm making sure that I will get a environment similar to Linux, and that is what it is useful here. Okay, so now if you take, there is no content here, and all those things that you are going to create will be present in this folder. Okay, so it is only for testing purpose. If you want, even you can create something similar, or you can create a new folder of your own name under C drive or D drive or anywhere in your Linux operating system and work onto that. Okay, so now what is that we are going to do? So the first thing what I have to do is we have to create a central repository or a bare repository. Okay, so let us start with the process. So now what we will do is, first we will create a central repository or a bare repository, and from there we will allow users to create new workspace, or it is just like how you will be doing in the production we will do. So first thing what we will do is create a bare repository or a central repository where we will be only storing changes, and from that bare repository or central repository we will create the local workspace for user, and we will do the changes in that local workspace or the non-bare repositories. Okay, so now how do you create a bare repository? You need to use a command called git init, wherein init stands for initialization, and you have to pass an option called -bare, where bare means creating a bare repository. If you don't pass the option -bare, then it will create a non-bare repository. And as I said, we will follow the process of creating the bare repositories first. So for that, let us first create a directory, and I'll use the command called mkdir to create a directory. And again, this is a Linux based command. Okay, so I will create something called central.git. Okay, and if you see, you will have a folder, and I will go inside central.git using the command cd. And once you are here, what is that we have to do is we have to run this command called git init bare. Okay, so now if you see, when I ran the command git init bare, it clearly tells that you are creating a repository. So what kind of repository it is? It is a bare repository which we have created, and initially it is saying that it is an empty repository because we don't have anything. We are creating a repository from scratch. Okay, now once this is done, let us proceed by creating a non-bare repository based on this. So typically in production, what will happen is users will have their own workspace. Once they finish their changes in their local workspace, they will come back and dump all the changes to this, so that any user who is trying to create a new workspace or a new repository will be based on the central repository. Okay, so in that case, how are we going to create a new workspace or a new non-bare repository inside the workspace so that we can do some modifications based on this? So for that, we will use a command called git clone. Okay, so for that, what you have to do is come outside of the directory by giving cd double dot, so that now if you see, you will be present in this directory. Okay, so now if you issue the command called git clone, and for this you have to give two parameters, wherein the first parameters is the central repository's name. Okay, and then it is the new workspace name which you want to use, or simply to put it in the technical terms, you have to give the name of the bare repository followed by the your non-bare repository which you want to work on. Okay, this is what you have to give. So in our case, if you see, where is our bare repository? It is this place, central.git, right? That is what we created. And currently, if you see, it is in the same directory where we are working, the directory is present. So simply what we can do is, we can say git clone and the name of the repository space, what is the new workspace which you want to create? Okay, so I will say new workspace, and I will say new workspace 01. Okay, so see what is it going to do. So now by doing this, Git is going to create a non-bare repository called new workspace 01, where we can do the modification, store and do everything. Wherein what exactly is this? This is a copy or a clone of this. So as the name indicates, clone means duplication, right? So when you run the command called git clone, it is going to take a complete copy of whatever is present in the central.git, and it is going to create a new workspace called new workspace 01 or a non-bear repository where we can start doing all the changes inside this. Okay, so now let's go inside this new workspace. Let me clear the screen. So now if you see, we are inside this new workspace called new workspace 01. Okay, and if you see the content inside it, it is empty. Why is it? Because we created a clone of a empty bare repository, right? The central.git, which is a bare repository, was empty. We didn't do anything. All we did was create a bare repository or created a central repository, and from that we did a clone. So obviously even the clone or the new workspace will also be empty, right? So now once we have done this step, let's proceed with creating the files. Okay, so now what I'll do is, let me first create a dummy file. So in Linux, there's a command called touch to create a dummy file. So for example, if I simply say 1.java, that is touch1.java, what it is going to do is, see, it will create an empty file called 1.java. Okay. So now what is that we have done? We have created a new file called 1.java. And now if you ask git, what is that we have done by issuing the command called git status? Okay, see what it tells. As soon as you enter the command called git status, what is it doing? You see, it is saying that this file, whatever that you have created, is a untracked file. And what is it asking to do? It is asking us to do the initial commit. That means this file is not being recognized by the repository. Please create the first commit or the first check-in of this file is what it is going to say. Okay, so let me go back to this and show you what is that I was saying. So right now, what is that you did? You are working on the working directory, and that is what you have created the file. That is manually or physically you can see the files, right? So as soon as you create it, it is trying to check in the repository, do you have any new file? And as we know, this is a complete new workspace or a new repository. There is no content in it. So that is why this repository content is empty. But when it is trying to compare here, you are creating a new file called 1.java. So that is why it is saying that this file is untracked. Okay. So now, how is that we have to store this file permanently to the repository? Using two steps. That is, first you have to take the changes and put into the staging area, and after putting into the staging area you have to do the actual commit or the check-in. So that is two steps. So let us do the first step. So how do we add the changes what you have done on your working directory, that is physical changes, to the staging area is using the command called git add. So when you say git add and give the file name, what it is going to do, it is going to take the changes from the working directory and put into the staging area. Okay, so now see the state of the file. When you say git status, you see it is no more untracked. Why? Because you are putting the files into the staging area, which is recognized by the repository. Okay, and if you come back here, now this is the content what you have that you put into the staging area. Okay, so now that is why the color also gets changed, and it says that it is a new file which you are trying to do a initial commit. Okay, so you have done the staging area step wherein you have taken the changes what you have done in your working directory and you have put into the staging area. Okay, now after you have put into the staging area, Git would have taken the snapshot. So now what is that we should be doing? We should be doing a check-in or committing these changes, whatever is that. That is, we are creating a new file. So what we will do is, we will use a command called commit. So as the name indicates, commit means you are doing a check-in. Okay. Now, when you are doing a commit, you have to use an option called -m, which is going to be used to give some message for this comment. Okay, now why is it required? We will come to know a little earlier, because it is not easy to identify a commit ID in Git. Okay, so for that very purpose, whatever that you are trying to store permanently into the repository, you need to identify quickly. For that purpose, we will use a message through which we can try to know at any point of time what is that you have done in that commit or check-in. So we will say first check-in. Okay, so now once you have done, what is that Git is going to do? It would have taken the changes and stored permanently into the repository. Now, as soon as it has stored permanently into the repository, whatever content you had here has been stored here, right? So now if you say git status, you see it says there is no changes that is present. That means all the files are in unmodified state, because whatever that you have here is the same what you have here. Okay, that is how we do. So now let us try to do some changes on top of it and see how it is going to work. Okay, so now what I'll do is I will open this file, or simply I will put some content into this. Okay, so this is a command called echo, which will just print something on the command prompt. So now instead of printing it on the command prompt, what I'm saying is to put this content into the file directly. That is what this line means. That means take this line and directly store into the file 1.java. Okay, so if you want to see the content of this 1.java, you just use the command called cat that will give you the content of whatever is present in this file. So now if you see, this line 1 has been added into this file called 1.java, or 1.java has a content called line 1. Okay, now see what will happen if I say git status. So now if you see, this file is no more called as untracked. Why? Because we have already stored the content or something about this 1.java into the repository, right? So now Git knows that there is a file called 1.java. So that is why it is not called as untracked, or since Git is tracking this file or started tracking, it won't call it as untracked. But now instead of that, what is it saying? It is saying that modified, because if you go to the repository, the content of the file was empty. Whereas now what you have done is we have added some line or some content. So that is why when it is trying to compare the content of what you have in your working directory with what you have in the repository, it is trying to clearly say that there are some changes and this file has been modified. Okay, so now how is that you are going to take these changes and permanently store into the repository? First, you have to add it to the staging area by using the command git add and the file name. So now what it would have done is it would have added it, the changes whatever you have done to the staging area. And now if you run the command once again, you see it is showing it a green color, which means that it has taken into the staging area. And now it is clearly telling that you can proceed with the changes to commit it permanently. Okay, and how is that you're going to commit? You will say git commit followed by -m, and you will say some message. So I will say second commit. Okay, so now if you run a git status, what it will do, it would not show anything, because whatever changes that you have done has been taken into the repository and permanently stored. So now whatever you have here is already present here. That is why it calls and says that there is no changes that is present. Understanding the step on how do you do a commit? The commit will happen in two steps, wherein you don't have to do anything. Directly you start modifying the file, and once you modify the file, you do a git add so that the changes will be put into the staging area. And once it is put into the staging area, you will say git commit so that it will store it permanently into the repository. Getting that? Any doubts or questions so far?
Adam, have a doubt.
Yes,
Actually, you created a file called one.java over here, right?
yes.
So if we have created multiple files, maybe 3 or 4, and we have modified them, and if we have to commit only 1 or 2 files and not the remaining 2, then how can we go ahead with that?
Okay, that is what I'll be showing you next. So just bear with me for
Oh,
2 minutes.
sure, sure, sure.
Okay,
Sorry.
so is that clear with how do you commit or how do you store the changes to the repository permanently?
Yeah.
Yeah, Adam, it's me, Sam. Just one quick question.
Yes.
Like every time when you commit, do you have to name it? Like you first time you give first commit and second time you give second commit. So do we have to name every time we commit?
No, we are not actually naming it. M stands for a
Uh-huh.
message. So
Okay.
I will come to that. So why
Okay, so
is that?
sorry,
Yes.
sorry, go ahead.
No, no, go ahead.
Finish. Okay, I'm just saying, so just in case if you don't have any message, so you can just say that git space commit, that would commit, right? That's it, right? You
Exactly,
don't
it
have.
will commit. Yeah, the point here is exactly the same. So why is that we are giving a message called commit or first commit, second commit? Even without that, we can do. Now, if you go back to yesterday's class, if you remember, I said every time you do a commit, how is that Git is going to track this? It is with respect to creating a commit ID. Remember? So
Yeah,
now,
40,
how many
40
times have
characters.
we done the commit? We have done 2 commits. That means
Mhm.
Git should be having 2 references with respect to the 2 commits what we have done. Correct? So now, if you want to see what and all the commits that we have done, you can use the command called git log, wherein git log will show you all the commits that we have done from the latest order to the oldest order. Okay, so in that case, now if you see, what is this? It is nothing but a 40 long characters or digits which is used to identify that commit. Okay, so now if you see how many commits we did 2 commits. So like this, every time when you do a commit, you will be getting a 40 long characters. Now, just by looking at this, can you tell quickly what is that you did or what is the changes or what was the purpose of this commit? Can you just quickly tell it?
No,
It will not be
no.
possible.
Yeah, I got it.
So that is the reason it is mandatory to follow a practice of using a message. Now, if you see, I can quickly say that, okay, this is the first commit I did, and I think since it was the first time that we did by looking at the message. So like this, why we need it? Generally, when you take it for the development, the users or the developers will be giving some meaningful message through which they can identify what and all the changes has gone in internally. Okay, that is why. And not only that, if you see here, this commit ID also represents who is the author, what is the email ID that we should contact, and also the date and timestamp. So all these factors are included when you are creating this. So why do we use the configuration in the very first place? If you remember, now you can clearly say that this commit ID was did by this user and you can contact him this ID, and this was the time when it was done, and this was the purpose why it was done. Okay.
Clear, clear. Yeah.
Okay, so now going back to Shashank's question. So now what happens typically is it is not that you will be having only one file in your repository. So now if you think a repository is used to represent one product, right? That is what the very first class I told about the terminologies. So in that case, this workspace contains one repository and it is used to store and modify only one product's content. Okay, so as I was telling again, there might be more than hundreds or thousand files in each product. So in that case, Suppose if you have modified more than one file, then what is that you're going to do? So for every file, if you do a change and then if you create a commit ID, that means that you are going to store more than tons and tons of commit IDs, because every time you do a check-in, you will be getting a commit ID. Suppose if you have 100 files and each file will be modified like 1,000 times, that means 100 into 1,000 commit IDs is what you're going to have. Then it is going to be a big mess in maintaining everything. So in Git, if you see, when you are trying to do a commit, either you have an option of generally doing it file by file, or the best practice is to commit a set of changes. Okay, so what do you mean by set of changes is you can use a combination of many changes done to different files and you can store it as one commit ID, and Git can use this one commit ID as a reference to all the changes. So like this, you don't have to create multiple commit IDs. So in Git, always the practice is you go as the change set or set of change. So simply we call it as change set. So how is that we do? For example, let me create one more file. Okay, so what is that we have done? We have created a file called 2.java. Okay, what I'll do is let me add line 1 to this. Okay, and at the same time what we will do is we will add one more line called 2 to this 1.java. Okay, and generally if I say greater than symbol one time, that means it is going to overwrite the content, and if you say it two times, then it is going to append the content which is already existing. So if I say cat1.java, if you see, already we had line 1. On top of that, it has added or appended one more line called line 2. That is what. And if you see the content of the file 2.java, there is only one line. Okay, now if you say git status, do you see what it is saying? It is saying that there is two modifications you have done, wherein the first file called 1.java is modified, which means Git is tracking this file already because it has the reference in the repository, and that is why it is calling it as modified. But when compared to the repository, you have a new file called 2.java which is not being present in the repository. That is why it is going to call it as untracked files. Okay, so now how is that you are going to commit a set or a set of changes? So when you are using git add, rather than giving the file name, you simply use a dot. Okay, so generally in Linux operating system, when you say dot, it represents the current directory on which you are working. Okay, so what is the directory that you are working? This directory, that is whatever that you have here, right? So when you say git add space dot, then it will consider all the changes that you have done in your current working directory, that is this workspace. So whatever that you have done in your current workspace, it is going to consider all the changes. So now simply if you say git status once again, you see both of them has been added to the staging area. Okay, so now this is the only difference what you'll be doing. So rather than adding file name, if you simply just give the dot, it will take all the changes that you have done. If not, if you want to use only for a file, then you can just say git add space the file name. So now once this is done, if you simply say the same command commit and give a message, I will say adding first change set. Okay, so whatever that you have done, it will take and it will add. And these messages, if you see, these are nothing but some warning messages. And what does it represent is generally when you are trying to create a file in Windows, and if you try to open it in Unix, there will be some extra line characters at the end. Okay, that is what it is trying to show, because what I am trying to do is I am trying to create a file from Windows in the Linux format. That is why it is just giving some warning messages. But other than that, you don't have to worry about anything. So now if you see, what is that we have done? We have committed a change set, and simply if you say git log, you will be getting a new commit ID where this commit ID represents the set of changes what we have done. So like this, you can choose either to commit one particular change, or as a standard always go ahead with a change set. Okay, so going forward, this is what we will always be using. I'll be just simply saying git add dot, so that it will add everything to the staging area. And when you say commit, whatever that you have put into the staging area will be taken into the repository and it will commit it permanently. Getting that?
Yes, sir. That's clear.
Okay, so now if you see, when I say git log, the first thing what you need to know is, where is this present? All this information is present in the repository, correct? Now, the question comes, what is this? This is nothing but the place where you are modifying, or simply this represents your working directory. Okay, and as I said, staging area is a virtual place wherein you won't be able to see. But the question comes here is, where is the actual Git repository or the Git directory? Because working directory is the place where you see the files physically and modify, and that is what we are doing. But I said that every workspace will also have a Git repository, because that is the place from where you are getting all this information, right? When you say git status, git log, it is trying to fetch the information. So where is it been storing all this information? Where is that present in your workspace? Any guess? No guess? But still, do you think that the repository should be present in the same workspace?
Yes.
Okay. Now, if you see this, if you use this command called ls-a, that means it is going to list the hidden files. If you just say ls, it is going to display only the normal files. When you say ls-a, then it is going to show you the hidden folders or files. And now in Linux, if you create a file or a folder with the name dot in the beginning, then it is going to be in a format of hidden, which means normally a user cannot see, but it still will be present. Just like in Windows, you can hide a folder from a user, right? In the same way, if you create a file or folder with the name .git, then it will be a hidden file or folder. But now if you see, there is a directory called .git. Okay, and why is it being hidden? Because this is nothing but your actual repository. Okay, so this place where you are working acts as your working directory, and inside your working directory there will be a folder called .git or a directory called .git, which acts as the Git repository. And now if you see this, it has all the configuration or specification related to the repository. And this is going to contain some metadata. Metadata means all those system related files which only Git can understand. So why it is being hidden? Because all the information that whatever that you're trying to store will be present here. It is not like it will be present in simple text format, but in a format only the Git architecture can understand. So in that case, if we mess up anything with this files, any files which you find here, then Git will not be working properly. And that is why, just to make sure, if a user by mistake deletes it, then you will not be getting any content like this. So in order to avoid, it will be present as a hidden folder inside your working directory. So now, do you get this point? So what is this? In your Git, this is nothing but your Git workspace, where this directory itself acts as your working directory, where you can modify the files physically. And then, where is the exact Git directory or the repository? It is present in a folder called .git, so that any commands that you run, it will be going inside this git.git directory, and it will be working based on this. Getting the difference between where is your working directory and where is your Git repository now?
Yes, Adam, one quick question. Didn't we create that .git file, or was it created automatically? I guess we created, right?
No, where did we create it?
I remember you typing somewhere .git in the beginning. I did not make a note of it. I
This
forgot.
is what I did.
Yeah. So isn't that what we created, like central.git? Isn't that repository, central.git?
Yeah, this is a separate folder, right?
Oh,
You see, I am present in, okay, let me show it in Windows so that you will be clear. So this is what I did, right? First, I created this
mm-hmm,
folder, and inside this, I
mm-hmm.
created central.git. Okay. Now,
Okay, yes,
after
yes.
that, what we did, we created a clone from the central.git called new workspace01. So if you go inside it, we created only these two
Yeah,
files called 1.java, 2.java. So how did that .git
I,
came? It came when you ran the command called git clone. So automatically it created the clone of your central repository.
I got it.
Getting
So
it?
now this one is bare repository, right? Are we,
This is bare
is because
repository and this is non-bare
yeah.
repository.
Oh, okay.
So simple, you understand in this way. Anywhere where you can see the files and modify the files, then it is a non-bare.
Okay. Okay.
Okay, fine. So now, as I was saying, so every workspace will have its own repository. That means anything that you do in this repository is known only to this workspace. Do you understand this from the first class which I said?
Yes. Yes. Yes.
So now, if you see all this changes or all this references, whatever that we have created is present only in this .git directory or the Git repository for this workspace called new workspace 01, correct? Now, what we will do is, let us go to the central repository. Okay, so this is where we were working, right? Now I will go to the central repository. Okay, now if you see, even this is a repository. Okay, now the very first thing before I proceed now is, why did I give a name as central.git? I could have just given central, because if you come back and if you just see from the Windows or the operating system side, what are these two things? Both of them are folders or directories, right? Generally, in any operating system.
Yes.
Now,
Yes.
how will you identify whether this is a bare repository or a central repository and this is a non-bare repository or a user repository? How is that we can find out? Because both of them from the operating system, if you see, it is nothing but a directory. So in order to quickly differentiate between bare repository and non-bare repository, all the bare repositories or all the central repositories will be named with the convention of .git at the end with your name. That is what it represents. So suppose if I create a central repository called Adam, simply I will create it by the name adam.git, so that I can quickly identify that adam.git is a bare repository or a central repository. Getting the point? It is nothing but
Yes.
a naming convention which people who work on Git follow. So now at any point of time, anywhere, if you see a .git at the end, then it is a central repository or a bare repository.
Very good. Adam, one quick question. So we give .git for our convenience, not for system to understand, right?
System doesn't know anything about that. It is only for
Yeah.
our understanding. I can still
Okay.
give
Okay.
a .git here, but it is a naming convention
Yeah.
which is followed throughout whoever is going to
Yeah.
work on Git.
I understand. I got it. You answered my question. Thank you.
Okay, now, so as I was saying, when you go to the central, so that is why I don't call it a central.git. I'll be just calling it a central repository. Okay, so now if you go to the central repository, if you see, it clearly says this is a bare repository. Okay, now even this has a repository inside it. Typically it is a workspace, and this also has a repository which is of type bare. Okay, now see what happens if I type git log. So it says there is nothing available. Why is it? It is because even though we have created this workspace from this workspace, or this repository was created from this repository is local to this workspace, and whatever the repository you have here and you're trying to get the commands output is local to this. So all these changes, whatever you have done, is local only to this repository only. So like this, a user can continue to store all the changes in his workspace until he wishes, and whenever he feels like he wants to share it with others, he can do. If not, remember, like this, you can do as many changes that you want in your workspace, and only this workspace knows about all these changes, or only the repository which is present in this workspace contains all these changes. Is that clear?
Yes.
Yeah.
Shashank, is that clear?
Yes.
Okay, now let me go to this scenario now. So as I was saying here, we have done some changes and we were storing it. Now, if I want to share it with someone, as a standard policy, what we will do is we will push the changes from our local workspace to the central repository, so that if any user or any other user wants to take, rather than he referring to our computer or our machine, he can go and refer to the central repository, which will be easy for others also, because like this, there can be many users who are doing changes in their space, and everyone will be updating this local from the local to the central repository. So now if any new user who wants to take the latest changes, rather than referring and finding out who and all are the users who are modifying, he can just refer one place called the central repository, from where he can get all the changes. Okay, so in the same concept, now how is that we are going to update the central repository with the changes what we have done? Okay, so for that we have to simply use a command called git push. Okay, so when you say git push, for git push you have to give two parameters. Okay, so the first parameter is the source. Okay, so what is the source workspace or the repository that you have to specify? And then the second thing is, what is the destination repository that you want to put it? Or simply you can tell it what is the local repository which you want to consider, and then what is the central repository to which you want to put the changes. Okay, so this is how you will say. But in Git, we have an option where if you don't say all these things, by default, Git will understand that from where did we create this workspace? We created it from this central repository, right? So automatically it will push the changes to its origin. So what is the origin of this? This central repository, right? So now if you say git push, you see, automatically it will try to take all the changes that you have done and it will put it to the origin. So what is the origin of this? This is the repository, correct? So it is going to put it. So now if you go ahead and see, you will get all the changes that you have done in this repository to the central repository. Okay, so now like this, every user, once they have done the changes in their local workspace or the non-bear repository, they will push the changes to the central repository. Getting it?
Got it, Adam. I'm just trying to just trying to make sure that I understood correct. So you're saying that when you don't give the names of the non-bear repository and bear repositories, when you just say git space push, it would just push the non-bear repositories to the bear repositories from where it was cloned, right?
Exactly.
Okay.
And
Thank you.
how is that going to work is what we had given a configuration called push.default as simple. You remember there was a third configuration which we did along with the username and the email.
Yes.
That is
Simple,
what
I guess.
it is going to
Yeah.
help here. Okay,
Okay.
so that is the purpose. We gave that as push.default. Suppose if you have not set that configuration, then this will not work as easily. Then you have to specify where is the source and where is the destination. But if you use that configuration called push.default, then as soon as you enter the git push, automatically it will know, because this workspace will store the information of the origin from where it has cloned. And that is why if you see, automatically it takes the data and it puts it. Getting it?
Yeah. Yes, Adam.
Okay, so now if a user wants, he can create a new workspace out of this and he can work. Okay, so now let me show that also. So if you take this, now we have come out, right? If I once again do a git clone of the central repository, and now I will say new workspace 02. Okay, so if you see, you have created a new workspace called 02, and if you go inside it, what is that you have done? You have cloned this central repository. So whatever is the content of the central repository at that point of time is what it is going to give us here. Okay, and simply now if you just say git log, you're going to get back everything. And going forward, any specific change that you do here will be present only in this. For example, let us try to add one new file. I'll say 3.java. Okay, I'll just add it and I'll say commit and I'll say first check in from new workspace 2. Okay, so you got this, and now if you say git log, you see you would have got something additional. All right, and is it present in all the other workspaces? No, it is present only in this. Let us cross check that also. So if you say git log here, you see this is not present. I mean, this latest B07E is not present. It is present only in this. Is it present in the other one, the new workspace 01? You see, this is the latest. So this change, whatever that you have done, is present and known only to this workspace. And now, how is that you will allow this changes to be taken into the central repository? Simply you say
Push.
git push. Okay, so automatically it will go to the central repository. And now if you say git log here, you would have got this. Okay, so this is how you will be updating the central repository with the changes what you have done in the local repository. Okay, using the command called push. Now, this is the general scenario on how people would be creating new workspace. Okay, this is absolutely fine. But think about this scenario. What will happen to this user who is working on this workspace called new 01? He is still working on some old change, right? Now, if he wants to get the new changes what he has done, Should he be creating a new workspace again? Typically, no. Why? Because he already has a workspace based on the same central repository, right? So he doesn't have to create a new workspace. So is there any way where can he update his existing workspace with the changes that is present in the central repository? That means the opposite of push. Push means from your local workspace, you are updating to the central repository. Now, what is the scenario I am saying is you want to update your local workspace with the latest content in the central repository. So as the name indicates push, what is the opposite of push? It is simple pull. Okay, or
Up.
sorry.
No, never mind, never mind.
Okay, you can say pull or fetch, both are the same. So now if you say git pull from this workspace, see what is it going to do? It will automatically go to the origin, that is the central repository, and it will get the latest commit ID which is not present here. So if you see this, B07 was the latest which is available in the central repository, and that is not available here, right? So now look at this. If you say git log, it would have got this latest into this workspace. Not only that, if you say ls, it would have also got the contents of the reference. So this is how, when you say pull, what it is going to do, it is going to fetch the latest content from the central repository to your local repository. Okay, so it is saying that it is up to date because whatever the content you have in the central repository is the same what you have in your in your local workspace. So push means taking the content from your local workspace and putting it into the central repository. And pull means from the central repository, you take the latest change and update your local workspace. That is what we call it as pull and push. Getting it? So this is how a general scenario of what you will be doing. So you will be working on your workspaces, and based on the need, either you will put the content into the repository or the central repository or get it back from the central repository. Getting it?
Yes, yes.